Okay, there we go. Come back to Zoom. Okay, here we go. Yeah, before we get started, I just want to go over a little bit. I know I've said this already, but I'm going to repeat it so we don't forget. So guys, remember the final is going to be open December 4th, that last Friday before study, actually before finals. The finals week is actually the next week, but we do a Common College Algebra final on December 4th. It's the Friday of study day. I'll open that up. You've got 2.5 hours to take it. It's just like all the tests we've taken before. You've got to get it done that day. If you cannot do that, please get in touch with me, and I will we'll work something out, make an accommodation. It's not a big deal, but you need to get with me before that day, and don't come to me on that day unless something just outside of your purview or something outside circumstance that happens on that day. Get with me beforehand and say, hey, Mr. Shirley, I can't make it that day because of whatever. Oh, no, that's fine. I'll go. So today, Janie brings this up because I mentioned it earlier before I ran up to my office. You're going to need your calculator. If you don't, just follow along with mine, and I'll tell you what buttons to press. It's not a big deal. It's going to help us out a lot to make these questions a lot quicker to solve, okay, once we get there. So, yeah, today we're going to go over section 3.4. That means we've got a test coming up because this will be the last section before the test. And I'm going to open the test after today. Okay, so you'll have over the weekend to take the test, just like before, and you'll be good to go. So I'll probably just open up the test till Monday. So you'll have the weekend and Monday to do it. It's the one in the syllabus, Amanda, we went over. What day are you opening the test? Oh, are you talking about test 4, Brianna? I'm opening today, okay? That's on my to-do list for today to open it up. But yeah, the calculator, it's on the syllabus. It's a TI 83 or 84. And we went over it that first day of class. And I probably said something to the effect of, hey, we won't need it right now, but you'll need it, sooner than later kind of thing. But so let's start 3.4 now, which is on really solving zeros. Hold on, let me highlight this. I've been this little guy the whole time. Yeah, 3.4, which now we're going to really get to solving zeros. So now I'm going to give you an equation, and then I'm just going to ask you to solve for all the solutions, zeros, roots. Remember, they're all the same thing. So let's kick this over to my document camera, and then we can get rocking and rolling. Hold on, section 3.4. See if this is the right height. Yeah, you can find them online pretty dang cheap. Do not buy them from the bookstore or Walmart's not too bad. They've come down at Walmart, but they're not $20. Okay, so first off, let's look at 3.4. The very first thing we need to talk about in 3.4 is called the rational zero theorem. I believe that's the name of it. Let me get there. Yeah, rational zero theorem. I guess before I even get there, let's talk a little bit about these zeros. If you're given a function, let's say f of x equals, and I'm going to steal one out of here. Hold on. One that. Give me just a second, guys. Book throws gives you one type of example and then gives you 4 different other types of examples. Hold on. Let me find one that I like. Yeah, 2x cubed plus x squared minus 3x plus 1. Oh, this isn't the best example, but it'll do. Okay, so let's go over actually the number of zeros we have first. So remember, and I've talked about this plenty in the last 2 sections, the degree tells us how many zeros we have. So we know we have 3 zeros for this function. Now, they might repeat. We might have 3 of the same zeros, but we have 3 zeros total. We can't have 4, 5, 6, 7, or 8. Something else that we need to talk about is that what is a rational zero? Well, a rational zero is any zero you can write as a over b where A and B are integers. So like examples of rational numbers or rational zeros would be like 1/2, -7, because you can write that as -7/1, 3, 4/3. These are all considered rational numbers, okay? Anything you can write as a fraction where you have an integer over an integer. So 4/3, 1/2, 3, which is really 3/1. All of those are rational numbers. Irrational would be like the square root of 2 or pi or something like that. I can't think of any other irrationals. Yeah, square root of 5. Things that don't simplify with the square root, those were all considered irrational. So this rational zero theorem only works for rational zeros. And what you're really finding is the potential rational zeros. That's what the theorem gives us, potential, okay? It doesn't tell us what the zeros are. It really gives us a pool of numbers that if we have a rational zero, it has to come from this pool of numbers, okay? So I'm going to show you how to do this, but I need you to understand what we're finding here. It's just a pool of potential rational zeros. And the way you find it actually is from the leading coefficient and the constant, okay? It's from the factors of each. So your book actually defines, I think they call it like P over Q. Let me get back to the actual page. So I'm using their terminology. Yeah, this is on page 377. P is a factor of the constant term. So our constant's 1, it's a little easier. So the only factor for 1 is 1, right? 1 divided by 1 is 1. The Q, though, is 2. So the factors of 2, the 2 is the leading coefficient. The factors of 2 are 2 and 1, okay? So the way I work this, if I want to find all the potential rational zeros, I'm going to make this little bracket notation. And I'm going to divide every P by every Q. So I'm going to take the 1 and divide it by 2. Now look, you have to attach a plus or minus. So you've really found 2 potential zeros here, plus or minus 1/2. Then I take the 1 and I divide it by 1. And you attach the plus or minus. Now notice there's no other combinations here. I'll do a more complex one here in a minute, okay? But it turns out if this function has a potential zero, it has to be positive 1/2, negative 1/2, positive 1, or negative 1. So I'm going to write it like this. Ooh. Okay, like that. That's all my potential rational zeros. Positive 1/2, negative 1/2, positive 1, negative 1. Now I'm going to come back to this to solve it here in a minute, okay? But I just wanted to do an example of just finding the potential rational zeros, okay? Let me do one that's a little more complex to show you, that's just a better example. This isn't the best example, okay? It's kind of a basic example, which makes it not as good for an introduction example. So if we looked at something like, let me steal kind of more of a more complex polynomial. Yeah, let's look at, this is number 48, okay? Now, all I'm going to do is find the potential zeros for this. We'll come back later maybe and solve it all. But for now, I'm going to find the potential rational zeros. So we've got f of x equals 2x to the 4th plus 3x cubed. This is on page 387, guys. 2x to the 4th, 3x cubed minus 11x squared minus 9x plus 15. And you'll notice in the example, actually, the instructions say find all zeros of a polynomial function to solve the given polynomial equation. Use the rational zero theorem. So this is the first part. They're wanting us to use the rational zero theorem. And the rational zero theorem says, hey, give me the pool of all the potential rational zeros. Okay, give me a minute. I got something. So first off, we're going to look at, remember the P is your constant, so 15. And 15 has more than one factor, right? We've got 15, 5, 3, and 1. these are all the factors of 15. All of these numbers are divisible into 15, right? The Q is going to be the constant, or I'm sorry, the leading coefficient, which is 2, which is only 2 and 1. Those are the only two factors of 2. This one's going to have a lot more potential rational zeros, okay? So here's how I go through this. I go through each P first, and I divide it by all the Q's, okay? So I do 15. I'm going to start with 15 divided by 2. So 15 halves is a potential rational zero. 15 divided by 1, well, that's just 15. That's a potential rational zero. Then I go to the 5. Look, there's no more Q's to divide it by, right? So then I go to the 5. 5 divided by 2. 5 divided by 1, that's just 5. And then I go to the 3. 3 divided by 2. And then 3 divided by 1, that's just 3. And then lastly, the 1 and the 1, or 1/2 and the 1, right? 1/2. Oh, I'm running out of room. And 1. Look, this is a huge pool of potential rational zeros. So 1, 2, 3, 4, 5, 6, 7, 8, really 16 potential rational zeros. Now, we know at most we can have 4, right? But they're giving us 16 options here. And I'll show you how to use this here in a minute. We have to learn how to find this pool first. And then I'm going to show you how we're going to use it, okay? Then I'll show you how we're going to use it with kind of an easier example, actually. A lot more like the one that we tried at first, okay? Questions about this other than, okay, I probably just need to try it a few more times and see what Mr. Shirley's talking about, okay? Let's see here. Okay. Let me do another one of these, and it's going to lead us into the next really part, which is solving all of these down, okay? This is number 2 on page 386. So it says f of x. This is number 2. Oh, I wrote f of 2. Number 2, f of x equals x cubed plus 3x squared minus 6x minus 8, okay? And first, actually, this question just asked to use the rational zero theorem to list all possible rational zeros. I'm going to continue on and solve all of this one, okay? But let's find the rational zeros here. So my numerator comes from the constant. Look, it doesn't matter that it's -8 because we're going to attach plus or minuses on them anyway, okay? But I got to think of all the factors of 8. Well, 8's divisible by 8. 4 goes into 8. 2 goes into 8, and then 1 goes into 8. 1 will always be a factor, okay? And then the leading coefficient here is 1. Well, that's nice because it's only 1. 1's the only thing divisible by 1. So therefore, the potential rational zeros on these are going to be nice. It's all whole numbers. 8 divided by 1 is 8, right? 4 divided by 1 is 4. 2 divided by 1 is 2. And 1 divided by 1 is just 1. Ooh, that's a goofy bracket. That's a bracket. Does not look right. There we go. Okay. So we've got 1, 2, 3, 4. We really have 8 potential rational zeros. Now, we've only got 3 zeros here, right? So that's kind of neat. But we got to figure out. So now that's part A. We'll say that's part A. We had to find the potential rational zeros. Now let's solve. Okay, the way we solve these, the long way is to go through these and figure out which one is a 0, okay? Which one of these guys is a 0? And look, I'm going to do this the long way so you can appreciate the short way, okay? I know that's goofy. That sounds like a horrible way of parenting, but and I'm not your parent. But, you've done this with your kids probably at some point. But, I've got to show you this so you appreciate it later on when we get there. But let's see the proper way to do this. Or if you forgot your calculator on the test, or your calculator goes dead on the test, this is how you would solve this without the calculator. So I'm going to have to go through and test each one of these. Now, I have no idea what the 0 is here. The book, that's not what the book tells me, okay? So I might get it on the first try, I might get it on the last try. But I'm going to start and just work my way down. Remember, if I can divide out and get a 0 remainder, that means that number is a 0. These are potential zeros. And so if I get back a remainder of 0, it tells me that's a 0. So I'm going to start with 8. Okay, I'm going to start with 8. Remember, it's 1, 3, -6, -8. If you did the homework yesterday, this is going to be the easy part. Okay, so bring down the 1, 8, 11, 88. Oh, this is going to get away from me real fast. 86 minus 6, 88 minus 6 is 82. Look, I can tell you this is going to be some big number, and it's not going to be 0. Okay, so I'm not worried about this. But what that tells me is that 8 is not a 0. So now I'm going to go to -8. Same thing, 1, 3, -6, -8. So bring down the 1, -8, -5, 40. Oh, this is still going to be a big number. 39. That's a big number. That's not 0. So therefore, 8 and -8 are not 0. So I know these two are not 0. So I'm going to go on to the 4 now. And look, I have no idea. I want you to know I've done this for over a decade. I can't choose which one of these is zeros. I have no idea by looking at the equation. Okay, I can graph it real fast and get it right, but I can't do it by the equation. So 1, 3, -6, -8. So 1, 4, 7, 28, 22, 88, 80. Not 0. That's all that matters. So then let's do the -4. So 1, 3, -6, -8. So bring down the 1, -4. Okay, this has potential because we're going to get smaller numbers here. So -1, +4, -2, +8, 0. Yay! Right? We drew smiley faces. We found it. We found a 0. Ooh, and we do the little I found a 0 dance. I'm doing it behind Zoom right now. You can't see it because you're on the document camera. Okay? But what that means, now, if you did the homework at the end of 3.3, you know how to finish this now. Because what we've done on our own is found one of the zeros. We can divide it out and find the last two zeros because it's going to leave us with a quadratic equation. So I'm going to do that, but you'll see from here on out, this is a 3.3 example. Okay, so I'm going to pause it right here and say, do you have any questions about this process? You guys have any questions? I'll give you a minute to kind of let it soak in. And I understand if it's like, no, I just need to see this like five or six times, because that's what we're going to be doing. You're going to be seeing this about 5 or 6 times, maybe more if we can get more examples in. Okay, so we know that -4 is a 0. We put it in, we divided it out, we got a remainder of 0. So now we need to keep going with this. So what we know now, remember, if -4 was the 0, x plus 4 was the factor, right? That was how they went together. And it leaves us with, now remember, these are the coefficients of the quadratic. X squared minus x minus 2. Hey, this factors. We just weren't to the zeros yet. This factors into x minus 2 and x plus 1. Multiplies to give you -2, adds to give you -1. Hey, boom shakalaka. There's all my zeros. X equals -1. 2, cool. Okay. Now I know that question didn't ask you to solve. This was just me going on to the next type of example, which is solving these completely. Okay. Questions, guys. And we could graph this if we wanted to. Remember, on a graph, this one would have been easy to see the zeros because they go through the x-axis, right? -4, +2, -1. We know the end behavior. It's up and to the right, down and to the left. It goes through because each one of these happens only once. So it looks something like that. We would have seen real quickly on the graph, which is why I suggest getting the calculator. We could see real quickly on the graph what the zeros are for this one because it was 3 nice integer zeros. Okay. Questions? Okay. Let's go back now to this one, which was that first example, and we're going to finish it up. So we found the potential rational zeros, right? We'll call again that part A, find the zeros. Now we're going to solve it. So what's nice is I only have 4 potentials now. So let's see which one of these works. I'm going to start with 1/2. And I know you're thinking, why would you start with 1/2? It's because I have an inkling that either 1/2 or -1/2 is the zero, because your book likes doing that. It has nothing to do with me seeing this and knowing, okay? So I'm going to divide the positive 1/2 out first. Bring down the 2. 2 times 1/2 is just 1. 2, right? 2 times 1/2 is 1. -2, I was right. -2 times 1/2, -1. And I got back 0. Bam. Man, that was quick. Look, I got so lucky. That was just getting lucky. The very first one I chose was the 0. It might have been -1, and I would have had to have gone through +1/2, -1/2, +1, -1, right? But the way we're working this without a calculator, I just got really lucky that the first one potential 0 I plugged in turned out to be the 0. So let's see what we've got going on then. We got f of x equals, now if 1/2 is the 0, x minus 1/2 is the factor, right? And then this is our, remember, these are our coefficients. So 2x squared plus 2x minus 2, okay? Okay, I'm going to slow it down here. We've got to this point, but we've seen this point before. We saw this at the end of the last lecture. Now, look, notice all 3 of these have a 2, so we can factor the 2 out. It'll make it easier because the numbers will be smaller. So I'm going to take the 2 out, and I'm going to put it at the very beginning. Oh, I've done that twice now. X minus 1/2. This would become x squared plus x minus 1, right? X squared plus x minus 1. Now look, what's different about every single example we've done so far compared to this one is that this does not factor. You can't multiply 2 numbers to get -1 and add up to get a +1. Actually, the only thing that multiplies to get -1 is -1 and 1, and that adds up to 0, okay? So this quadratic does not factor, which I believe every example in 3 and the ones that kind of brought it up in 3.2, they all factored completely. But now we're getting to where the last 2 zeros are going to be irrational, okay, right? They're not going to come from this pool because they're not going to be rational. If it doesn't factor, it's not rational, okay? If it doesn't factor, you're not going to wind up with nice rational numbers. So if it doesn't factor, we've got to solve it either by the quadratic equation, the completing the square, your calculator if you've got the calculator way of doing it. But I'm going to just pop this in the quadratic equation. I have to find the last 2 zeros here. So x equals -b plus or minus the square root, b squared minus 4 times a times c, all over 2 times a. I am straight up running out of room here, guys. Underneath the radical, I get 1 plus 4, right? -4 times 1 times -1. That's a +4. So 1 plus 4, I get 5. That's not going to simplify, which is good. It makes it where I don't have to use as much space over here. So I wind up with x equals -1 plus or minus the square root of 5 all over 2. This doesn't simplify. There's nothing that divides evenly into all 3 parts. So we have found our last 2 zeros. They just turned out to be irrational. Okay, they weren't rational because they didn't factor. Okay, so they weren't rational numbers. They're irrational. They're real numbers. They're somewhere, but they're irrational. So let's write that down. Remember, the goal was to solve this. So my solutions are 1/2, -1 plus the square root of 5 over 2, and -1 minus the square root of 5 over 2. Okay, it came from this quadratic equation. Questions about that? Okay, I'm going to tie it into the graph now because these are real numbers. Now we're going to wind up getting two imaginary numbers that don't cross the axes, but these two cross the axis. So I'm going to take my calculator out just to get a decimal so I know where it crosses on the axis. So I'm going to say, take out the calculator, and all I'm going to do is find this first, the first irrational one. So -1 plus the square root of 5, come out of that, that's the numerator, divided by 2. Turns out to be, no, it's hard to see, 0.618. So we'll just say for us, this is, so I'll do green for like, oh, this is just my estimate. So 1/2, 0.6, that's really close to 1/2. And then let's do the same thing, but with -1/2. So go back here, put a minus, and I get -1.6. Okay, so for the graph, look, these two are really close together, 0.5 and 0.6. So I'm going to zoom in real close here. Look, if that's 1, I'm going to draw all over this one. I'm going to make a little thing for 1/2 here. Here's 1, here's -1. We know -1.6, it's about right there. But then 0.5 and 0.6 are about right there. So what happens now, we have the same in behavior, right? +2, and it's odd. So what's happening here, it's coming down, goes through, goes up to 1, goes that way. Okay, I know that's goofy, but these two are really close together. So it'd be kind of hard to see in the calculator, actually. Okay. Trying to tie this all together, because when we use the calculator to make this a lot easier, you'll go, oh, that's why he did all that. That makes sense. Okay. But before I do that, I want you to realize something about irrational zeros. So I'm going to write this down because it's important. Okay. I'm going to write this down because it's important. If you're still writing that, I'll leave it up there. Irrational and imaginary zeros always occur as conjugates. Okay, and really I should say, if you want to think of a conjugate, so as paired conjugates. Conjugates are always paired. It's kind of pointless to put that in there, but just to let you know that that means 2. So for here, like these were our 2 irrational zeros. These are actually conjugates. Now I'm gonna divide the 2 on both of them because it winds up being -1/2 plus the square root of 5/2 and -1/2 minus the square root of 5/2. Okay, if you divide the 2 by both things in the numerator. This is a conjugate. Remember, conjugates are A plus B and A minus B. Okay, A plus B and A minus B are considered conjugates. And we had that here with these irrationals. -1/2 plus the square root of 5/2 and -1/2 minus the square root of 5/2. So if we have irrational or imaginary zeros, they always occur as pairs, okay? They always occur as pairs. Now, what that means for me when I make up examples is when I saw that this function was a third-degree polynomial, I knew this had to have at least one rational number because irrationals and imaginaries, which are the only 2 other options, irrational and imaginaries, always occur as pairs. So if I've got a third degree, at least one, now it could be all 3, right? But at least one has, at least one of these zeros has to be rational. It has to come from this pool, okay? At least one of those had to come from this pool because it's a third degree. Irrational imaginaries, which are not in this pool. These 2 types of numbers, not in this pool, because you're going to get weird square roots or you're going to get i's. Those, what am I trying to say? Yeah, the ones that aren't in this pool, the other 2 could be from that, and they wound up being from it, right? They're not being from that pool, right? So kind of neat. Now, where if you look at this other example we did earlier, it had the third degree. So I knew when I started this example, okay, at least one of these will work. Okay, at least one of these will work. I didn't tell you that at the time, but at least one of these will work. And we found out -4 worked, but it turns out if I would have divided 2 and -1 out first, the same thing would have happened. We could have gone on to get the other 2 as well. Okay, so it turns out all 3 of these were rational, right? But it could have been just 1 and 2 imaginaries, or 1 and 2 irrationals. And it's not that you have to know that, it's just that it helps us when we're solving these. It's kind of a tool to have in the knowledge toolbox, okay? If you watch too much of Mickey Mouse Playhouse right now, if you have a kiddo that watches that, you'll know that, you know, it's been so long since I've watched the show. The boys are a little bit older now, but I know there's something about the toolbox, Mickey Mouse toolbox or something like that. Anyway, it doesn't matter. So let's look at another one, and I'm going to show you what I'm talking about, how these occur in pairs, and I'll try to find one that's imaginary. Yeah. Let's say we had, let's see if I can find an imaginary one that's, yeah, okay. Oh, good. This one's written a little differently too. This is number 20 on page 387. And it says x cubed minus 5x squared plus 17x minus 13 equals 0. Now the question, look, this is an equation, not a function like the ones earlier. So this is an equation, and all they're going to do is they're going to ask it a little differently. It says list all potential or possible rational roots. So they're calling these solutions roots because it's an equation, not a function. I am treating this just like it was a function. I'm not going to do anything different. It just looks different because it's set up like an equation. So if I want the potential zeros or the potential roots, first I'm going to look at the constant, which is 13. And since it's, what's the word when it's only divisible by itself? Oh, prime. Since it's prime, it's only 13 and 1. And then the constant here is nice. It's just 1. So my potential zeros are plus or minus 13 and plus or minus 1. Now, here is where I can use the calculator and I don't have to check all 4 of these. Okay, so I'm going to show you, this is my first foray into using the calculator to make our life a little easier on this example. Now, I'm going to say logically, you should have got to this. Look, we could graph this, and where it crosses the y-axis has to be our 0, because we know with rational numbers, rational zeros, that's just x-intercepts. We solve these the same way as x-intercepts. So I'm going to go to y equals. Now, if you've never seen this before, I'm going to go slow. And if you don't have a calculator in front of you and you're like, oh my God, I need to see this again, just come back to this part of the lecture. Okay, let me focus to get it better. Okay, so I first off, hold on, let me clear this out. Second quit. So clear. Second. Shoot. Just turn it off. Okay, so this is the home screen. I'm going to hit the y equals button right there. Let me use my marker, okay? So I'm going to hit the y equals button. Boop. And what this does is we're going to make this, we're going to write this as our graph. We're going to call it y equals. So the way to bring x in, this button right here, catty corner from the second button, x, comma t, comma theta, comma n. I click that and it brings up x. Now I've got to raise it to the 3rd power. To do that, let me scooch over here a little bit. We're going to use this caret button. You can click the caret button, and what it does is it kicks it up to the exponents. And I clicked on 3. And then I have to hit over to get out of the exponent. So then I'm going to do a minus. Now look, there's a negative button at the very bottom here. That's for like -5 or -2. If you have subtraction, you need to use the actual minus button, which is below the times above the plus. Minus 5. Now I need to bring another x in. So x, comma t, comma theta, comma n. Square it. So caret 2. Get out of the exponent. Plus 17x. I don't have to worry about raising that to a power. Minus 13. Ooh. Okay. So I put this equation into the calculator. Okay. And I'm going to hit graph here. See that graph button? I'm going to hit graph. Boop. and it's going to graph this thing. And we're going to hope it go. There it is. Okay. Oh, it went away. That's fine. But look, it looks, and I've got some gunk on my calculator from using a Sharpie and not cleaning it off, but it looks like it goes through 1, right? Remember, that was our potential rational 0. Now, we can't see 13 on here. It's a little outside of the range, but I think this goes through 1. Now, if you're not sure, guess what? We can just divide it out. I can tell you it's not -1, right? -1's right there, and it definitely does not go through -1. So kind of eliminating possible zeros, it's not -1. I think it's 1. To be sure, you can hit the table. Do you see how like above the graph, it's got a table option? So I'm going to hit second to get the blue keys, and then I'm going to hit table. Oh, yeah, look at that. X equals 1 has a Y value of 0. Hey, remember, if we plugged in an X value and we got back 0, that meant it was a 0. I am like, what? Actually, now I'm 100% sure that X equals 0. I'm sorry, X equals 1 is a 0. And I got it from the calculator. That was nice of the calculator to do that. Okay. Now, if I didn't, I could have gone through and just divided each one of these out. Eventually, you would have got to 1 and you would have gotten to 0, kind of the way we did it before. Okay. So yeah, you can do it this way. It's not a big deal. You can do it the other way and it's fine. This way is just a little quicker. It gets us to the 0. So I'm going to go straight to solving this. Okay. So look, again, once you get that calculator ordered in, Amanda, if you come back and watch this, that would work. You kind of need it soon. So, because if I've got the test only open till Monday. But anyway, so let's go back. We know X equals 1 is a 0, so I'm going to divide 1 now. 1, -5, 17, -13. Bring down the 1, 1, -4, -4, 13, 13. Boom, it worked. Okay. If it didn't work, something was wrong with our math here. We knew 1 was a 0. We could see it on the graph, and it told us for 100% certainty in the table, okay, that we knew that it was a 0 because it went to Y equals 0. Okay, so no, we know 1's the 0, or 1 is a 0. I've got to divide. I actually have to do what I've been doing so far. Divide it out. We already did that. And then find the last 2 zeros. I know there's 2 other ones lingering out there. Okay. Questions, though, about what I did with the calculator. So all I'm doing with the calculator is really just visually seeing, hey, I don't have to plug in -1. It looks like it goes through 1. Oh, it definitely went through 1 from the table. Now, look, if our numbers are decimals, if our potential rational zeros are decimals, we can use it more for just deducing, hey, it's not all these other potential rationals. It's got to be one of like 2 or 3. Okay. So it helps us that way. It brings down the options. Okay. So let's do one, or let's do this one. So we get f of x equals x minus 1's the factor, right? Because 1 was the 0. Here's our leftover quotient, right? So that's our quadratic. This doesn't factor. The only thing that multiplies to get 13, positive 13, there's no way we could get it to add to be -4, right? 13, 1, -13, -1. So I'm going to use the quadratic on it. Negative b plus or minus the square root, b squared minus 4 times a times c all over 2 times a. Now our a is 1. So underneath the radical, I get 16. 4 times 13, that's a deck of cards. That's 52 if you've ever played 52 card pickup with your siblings or cousins. 16 minus 52 is -36. So now what we have is positive 4 plus or minus the square root of -36 all over 2. Now look, we've done a lot of these. That's why I'm zooming through this. This should be a quick review on quadratic. So 4 plus or minus, we know the square root of -36 is just 6i. So look, because it's 6i, there's no way we would have seen it on a graph. because the last two zeros are imaginary, they're not, this is the only place this graph is going to cross, okay? Because of the imaginary two zeros. Now it's all divisible by 2. We can divide everything by 2 here, and we wind up with 2 plus or minus 3i. Those are our last two zeros. So now we've got to solve this. That's what it asked for. So remember, the first 0 was 1, and then the other two zeros are 2 plus 3i and 2 minus 3i. And notice they occurred as conjugates. 2 plus 3i, 2 minus 3i. Okay, that's not a coincidence. We talked about it. And there's 3 of them. Not a coincidence because the degree is 3. Okay. Questions about this? Before I'm gonna give you one that's pretty similar, and I want you to solve it just so you see this process and try to do this process on your own. If you don't have a calculator, that's fine. You're just gonna have, it's gonna take you a little more time to find that 0, but it's not a big deal. Okay, not a big deal. Questions though about this one? This is a great example for the test that's going to be open by the end of the day. Okay. So let's look at, I didn't mean to slide in that hard. Okay, let's look at, let me find one that I think is a good example. Okay. Let's see here. I see some good examples. Actually, I might just do one that's back here. Hold on, guys. Give me just 1 second. Yeah. So I'm going to say f of x equals x cubed plus 7x squared plus 11x minus 3. So for part A, I want you to find all potential rational zeros. And for part B, I want you to solve. I'm just going to say solve the polynomial. It might look like solve polynomial / find all zeros. It might be asked a few different ways. Okay. Something like that. So try that one just like before. So find all the potential rationals and then solve it completely. I'm going to give you a little bit of time. I'm going to give you like at least a solid 5 or 6 minutes just to work on it and see if we can get there. Okay. And I've got to get some water. I'll be right back. Yeah, I'm going to start this. Keep working if you're working. Okay. So potential rationals, we've got a 3, which is just 3 and 1. And we've got a 1, right? So, okay, just like last time, it's only 4. Plus or minus 3 and plus or minus 1. So I'm going to go to the calculator. I'm going to cheat a little. And I'm going to put this in. So x cubed plus 7x squared plus 11x minus 3. So I'm going to graph it. Hopefully, okay, I can tell from this graph, let me see, I'll just kind of bring it up to you. I can tell from this graph, it does not go through +1 or -1. Do you guys see that? So look, I can kind of get rid of those two. Definitely not going through those. And it doesn't go through +3. That's easy to see. But it does look like it goes through -3. Now, it goes through these other two locations. I bet those are irrational. Okay, so I'm going to go to second table and check this out. At -3, I get back 0. So yeah, that tells me x equals 0 has, or I'm sorry, x equals -3 has to be the 0. And I'm going to divide it out to make sure. 1, 7, 11, -3. Oh, I don't know why I wrote this so big. Bring down the 1, I get -3, 4, -12, -1, +3, and 0. Okay. So, boom, I was right. Smiley face on the 0. And it turns out f of x equals, now the factor is x plus 3. What's left over is a nice little quadratic, x squared plus 4x minus 1. And it definitely does not factor. -1 doesn't multiply or add to give, two things that don't multiply to get -1 and add to +4. So I'm going to have to use the quadratic here. Remember we talked about the quadratic being our safety couch, right? Once we can get this thing into a quadratic, we're fine. We can find the last two by the quadratic equation. So -b plus or minus the square root, b squared minus 4 times a times c, all over 2a. Now, underneath the radical, I get 16 plus 4, right? 16, -4 times 1 times -1, +4. So I get 20. Oh, this thing simplifies. 20 is 10 times 2, 5 times 2. I can take a 2 out, right? And I'm left with a 5. So this winds up being -4 plus or minus, take the 2 out, and I'm left with the 5 all over 2. The 4 and the 2 are all divisible by 2. So it's -2 plus or minus the square root of 5. That's our last two zeros. So our 0, remember the goal was to solve. We knew that -3 was a 0. We know that -2 plus the square root of 5 is a 0. And -2 minus square root of 5 is a 0. Boom. We found them all. Okay. Questions about that? Now that you kind of had a chance to work one on your own. Okay. I'm going to keep rocking and rolling. I'm going to throw some curveballs at us now. Okay. Yep. So let's look at this first curveball. Curveball for a few reasons. F of x equals x to the 4th minus 6x squared minus 8x plus 24. Okay, the first curveball for this one is, hey, look, we have a 4th degree polynomial, right? So that means we're going to have 4 zeros. Now, for this one, they might all be irrational, okay? They might all be irrational. That's no good. But I haven't gotten over how to solve one that's all irrational. I promise on the test there won't be 4 that are just all irrational. If not, so what we're gonna have to do though, if it's not irrational, we're gonna have to divide this one out twice. We're gonna have to divide a 0 out to make it a 3rd degree polynomial, and then we're gonna have to divide another 0 out to make it a 2nd degree polynomial. Okay. So let's look at this one. Let's do the same thing with potential zeros. So I get 24's got a lot. 24, Lord, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Holy cow, that's a lot of numbers. Now, thankfully, the first number is just a 1. So our potentials are all from right here. So plus or minus 24. Oh, good. Our potential zero's going to be a nice integer, right? Which means it'll be, if we have rational zeros, they're going to be on the graph. So let's solve. Now, guys, I'm going to go straight to graphing this thing. I want to see what this thing looks like. So x raised to the 4th power minus 6x squared minus 8x plus 24. So I'm going to graph it. Takes it a minute. It's got a lot. It's thinking, oh, this is different. This graph isn't going through the x-axis. This graph is bouncing off the x-axis. So remember, if it touches, your book says touches, I use the word bounce. If it bounced, it means we had a multiplicity that was even. And so it's bouncing at 2 there. So I'm going to go to the table. Oh, yeah. See 2, how it goes to 0? It's definitely a 0. So I'm going to write that down. X equals 2 is a 0. But what's more important from this graph is that it bounces off the graph. So that means I'm going to divide 2 out more than once. I can divide it twice out. Okay. I might be able to divide it 4 times out. It might be 2 might be repeated 4 times as the 0. Okay. I don't think it is. But let me show you what I'm talking about. So I'm going to divide 2 out. Now look, guys, we don't have a 3rd degree term here. So we have to put in a 0. So 1, 0, negative 6, negative 8, and 24. 1, 2, 2, 4, negative 2, negative 4, negative 12, negative 24, 0. Checks out. Okay. So I'm going to write what we have going on now. Here's what we found out. We have found out that f of x equals x minus 2 is the factor because 2 is the 0. We've got x. Now remember, this is constant x squared, x cubed. So 1x cubed plus 2x squared minus 2x minus 12. Okay. So unlike before, when we divided the x out, we're not left with a nice quadratic to solve. We're left with a 3rd degree. Okay. Now I'll tell you, with a 3rd degree, you're gonna if you don't have a calculator, you're gonna have to start this whole process over again. So that's why you need a calculator ASAP. It's because of the calculator that we know it bounces. Okay, it's because of the calculator we know that this thing bounces. So what that means is I'm going to take this 3rd degree and I'm going to divide another 2 out. Now I'm going to divide it out of this 3rd degree because I know it doesn't. This x minus 1 as a factor, it can't happen just once. It bounces. It's got to happen at least twice or 4 times. Okay, so 1, 2, negative 2, and negative 12. That's the coefficients here. I'm focusing on this 3rd degree polynomial now. 1, 2, 4, 8, 6, 12, 0. Okay. Man, this is cool. Kind of go over here now. Here's what we know. F of x equals x minus 2. We already factored that out. This tells us 0 or 2 is a 0 again. So I'm going to factor that out. And what's nice is this leaves us with a quadratic, x squared plus 4x plus 6. Okay?
And now I'm going to go and assume that these last two zeros are going to be imaginary because it doesn't cross the axis anywhere else. Okay. So I'm going to assume these last two are imaginary, and I'm going to use the quadratic though to actually find them. So I'm going to use the quadratic to find the last two zeros. So x equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Okay. Underneath the radical, I get 16 minus 24. That's negative 8. Yeah. See, that's going to be imaginary because we're going to take the square root of negative 8, right? So negative 4 plus or minus the square root of negative 8 all over 2. So we get negative 4 plus or minus, 8 is 2 times 2 times 2. So I could take out a 2i, and I'm left with a 2 over 2. So it winds up being, these are all divisible by 2, so negative 2 plus or minus I square root of 2. I know that was a lot, but that's just solving quadratics. And guys, if you go see Althea in the tutoring center, she will give you the calculator or the program in your calculator that solves it automatically. So you don't have to do all that work. Okay. So let's look at the actual solutions though. We had 2. Now look, 2 really occurred twice, right? Wrote it out once, factored out again. You can write it twice if you want. Technically, you're not supposed to. Okay, so I'm not going to do it. So negative 2 plus I squared root of 2 and negative 2 plus I squared root of 2. Okay? And we have this nice, or the solutions. Now look, I know what you're thinking. You say, hey, Mr. Shirley, 1, 2, 3. That's 3 zeros. We've got a 4th degree polynomial. But remember, this multiplicity was 2. So really, we have 4 zeros. It just repeated itself. Okay? Questions. Now, that is a curveball question. And it's okay if you didn't quite grasp this completely, because when you're working on the homework, you're going to work up to this question. Okay? So don't get too downtrodden. If you're looking at this and going, what in the world is he talking about? Oh my gosh, OMG, right? It's okay. You need to work the homework first. And then when you get to this one, and if you're still OMGing, that's when you need to email me and I can try to help you out, okay? Or go to the tutoring center, email Althea, Miss Althea. Look, her email is tutoring@asumh.edu. Okay, and her name is Miss Daniels, Althea Daniels, and she is a godsend to this campus. She is free tutoring. I apologize if I have not mentioned her before. I think I might have mentioned her at the very beginning of we took the Dev 2 class. But you can set up an appointment over Zoom. You can come up to campus. I believe she can help you. I'm not sure what the rules are, but if you email her, she can set up a time to help you. And she has gotten a lot of people through this class over the years. She's been here, I believe, just as long as I have. Okay. And she's been great for students, period. Great for students. Okay. Question. Comments. Okay, let's do one that's a 4th degree, but it's not repeating. So we've got to figure out what the two are, what the 2 zeros are that can get us into the quadratic. Now, I'll tell you, this is at the very end, guys. So if we can do this one, we can probably do all of them. 3x to the 4th, this is number 50, okay, on page 387. 3x to the 4th minus 11x cubed minus 3x squared minus 6x plus 8 equals 0. Let me make sure I wrote this down right. 3x to the 4th minus 11x cubed minus 3x squared minus 6x plus 8 equals 0. Yeah. Now, look, I'm going to treat this like an equation. Now, of course, first thing is going to be find potentials. I'm just going to put potential. I don't have to write it all over again. We know it comes from 8, which is 8, 4, 2, and 1, and 3, which is just 3 and 1, right? So it's going to be plus or minus 8 thirds, plus or minus 8, plus or minus 4/3, plus or minus 4, plus or minus 2/3, plus or minus 2, and then plus or minus 1/3, plus or minus 1. Yeah, we got a lot going on. 1, 2, 3, 4, 5, 6, 7, 8, 16 different potential zeros. Now look, the graph's going to help us a lot on this one to kind of narrow down what these zeros are and are not. Okay, let's go to y equals, and I'm going to graph this thing. So I know it's not on your page here, but it was 3x, let's put this up, 3x to the 4th power minus 11x to the 3rd power minus 3x squared minus 6x plus 8. And I'm going to graph this bad boy. Eventually, it'll come on the screen. Come on. There it is. But it comes back up here. So, oh, there it is. Hello. Holy cow. Now, this one looks nice. It looks like it's a 4, right? 1, 2, 3, 4. I'm going to check that one. Oh, yeah, look at that. 4 is a 0. So I'm going to write that down. X equals 4 is a 0. I wrote it down. I know you guys can't see that. It's on the other side of the page. But now this other one, though, like this 0 right here, notice it's between 0 and 1. Oh, man. 0 and 1. Kind of close to 0.7. 0.7 is not one of our options, okay? But I can start eliminating ones that are, okay? I can start eliminating ones that are definitely not on this graph. I wish that glare wasn't there, okay? Hold on. I can move this a little bit and get the glare to go away. No, it ain't happening. There we go, okay? So I'm going to eliminate some that just, there's no way these could be our 0, okay? Look, 8 and -8 ain't happening. That one's going away, okay? 4/3, that's 1.33 repeating. It's not greater than 1. You guys can see that it is not to the right of that 1's digit. So, and it's not a negative. So that's going away. Definitely not, well, we know it's +4, but it's not -4, okay? We're going to put a check there for 4. 2/3, that is a maybe, okay? Not +2 and -2. 1/3, it might be 1/3, but it's not -1/3, okay? It's not +1 or -1. And it's not +8/3 here. I forgot that one. That's like 2.3 repeating. So I've got two options. It could either be +2/3, not negative, or +1/3, okay? I think from this graph, it's a little bigger than 1/3. I think it's 2/3, okay? So I'm going to second quit here. I think it's 2/3. Let me pull this out. There we go. Come on, focus. Okay. I think it's 2/3, so I'm going to go from there. Actually, I'm going to do the 2/3 first. I know it's 4. I know 4 is a 0 of this function because it crosses at 4. Okay. So I'm going to test the 2/3 by doing synthetic. Now it's 3. There's no missing terms here. 3, -11, -3, -6, and 8. So we get 3. 3 times 2/3, that's just 2. You can use a calculator for that. You get -9. -9 times 2/3, I think that's -6. That's -18 divided by 3. Yeah, -6. -9 again. Hey, I know that's -6. -12 times 2/3. Well, 12 times 2 is 24 divided by 3. Sure enough. -8. I was right. Okay. 2/3 wound up being our 0. So we kind of used the potentials to narrow down, right? Or actually, we used the graph, but we used the potentials just to narrow down which one of the potentials it could be. Even though we had 16 of these guys, there were ones that were definitely not zeros. Okay. So we got it down to 2/3. Okay, great. So let's see what we actually have here. X minus 2/3 is a 0, or a factor. We've got 3x. Now look, it was a fourth, so it's going to come down to a third. It's 9x squared minus 9x minus 12, right? So now I know if 4 was a zero of this function, then 4 has to be a zero of this function as well. Okay, so I'm going to divide a 4 out from there. So 3, -9, -9, -12. So bring down the 3, I get a 12. 3, I get a 12 again. 3, I get a 12 again. And I got 0. Okay, that's kind of goofy. 3's across the board. So I'm going to write what I've got going on. F of x equals, I factored out an x minus 2/3. Factored out an x minus 4 now. And what's nice is I'm left with a quadratic of 3's. Okay. Now, notice, remember that one example that we did where we could factor, like all 3 of these have 3's, right? 3, 3, 3. I'm going to factor 3 out to the front to make our numbers smaller. We did one of these earlier, right? So x squared plus 1, or plus 1x plus 1. So here's our quadratic. So I'm going to pop this in my quadratic equation to find the last two zeros. So x equals -b plus or minus a square root, b squared minus 4 times a times c, all over 2 times a. So I get x equals -1 plus or minus the square. Now, look, this would be 1 minus 4. So that's a -3 over 2. This is going to be -1. Now, look, it's a negative under the radical, so I can take an I out. 2. There's our last two zeros. Okay, now look, I'm going to write these all down now, though. Holy cow, let's see what we have. We factored a 2/3 out at the very beginning of this example. I know you're thinking I'm going fast, but I've got like 2 minutes left, guys. So I'm kind of rushing. And I want to show you this one. We factored a 4 out, and then we have our last two, which are imaginary. So -1 plus I squared of 3 over 2, and -1 minus I squared of 3 over 2. Okay. Boom, that's our zeros. Okay, that was number 50 in the homework. Okay, that was number 50 in the homework. Let me give you the I'll leave that up there. Actually, I'll write the homework here. Let me give you the homework for this exam or for this section. So I want you to do 1 through 23. These are all going to be odd. 1 through 23, and then you can skip over that middle part. And then 39 through 51. Now, I'll tell you, 39 through 51, they ask you, all these are going to be odd. It's on page 387. On the 39 through 51, they ask you for other stuff like Descartes' rule of signs and, maybe graphing it. That's fine. All I want you to do is find the zeros. I want you to list the potential zeros and find the zeros. Okay, that's what's going to be on this test. Okay, that's what's going to be on this test. Okay, I know that was a lot, but listen, you got to do the homework. This gets a lot easier when you do the homework. This is one of those repetition math things that gets a lot easier when you do the homework. Okay, do you guys have any questions? My time is up. Do you guys have any questions? Okay, so what I'm going to do is I'm going to open the test today, and I'll leave it open over the weekend, even into Monday. Okay, I'll leave Monday at midnight. I'll open it up till Monday midnight. That way, you've got time to get the homework. Yeah, I would definitely rewatch this. This is not an easy one, especially if you've got a kid running around in the background. This isn't the easiest section. Okay, so I'll open it up till Monday. Now, give me a minute to get it logged in because I've got a lot of errands I got to get done today, but it'll be in before the end of the day today. Okay, do you guys have any questions? Awesome. I will see you all on Monday. Tyler, You jumped in early. This is the next class, buddy. I'm going to close it out. Yeah, I'll close it out and I'll come back.